All right, diving in today, getting into something pretty foundational. We're talking about how we understand belief, imprecise probabilities. And for you, given your philosophical leanings, I think this would be right up your alley. It's not about checking out probability altogether. It's more like, well, what are the edges of it? Like, where does it maybe start to fray a bit? When we're not super certain, can our beliefs, can the way we represent those beliefs, can that be a little more, I don't know, a little less sharp?
Yeah, that's a good way to put it. A little less sharp, a little more nuanced, right?
Mm-hmm.
Like, do our models, the ones we normally use for belief, do they really hold up when we're in situations where, frankly, we just don't have all the pieces?
Yeah.
Is there a better way, philosophically speaking, to think about belief in those cases?
And that's where this Stanford Encyclopedia of Philosophy entry comes in. Imprecise probabilities, that's our source material today. It's a pretty thorough look at this whole idea that maybe, just maybe, what we believe isn't always perfectly clear-cut.
Exactly. And today's mission, specifically for someone like you who's steeped in philosophy, is to really unpack why this concept, this imprecise probability thing, has gotten so much attention, especially among philosophers who are really into epistemology and the whole nature of belief.
Yeah, it's like, can we even say we know something if we can't pin it down to a specific number? It's like questioning one of the basic building blocks of how we think about knowledge.
Absolutely.
Yeah.
It gets to the heart of how we represent what we think is true, especially when that truth is a little slippery.
In our source, right off the bat, they throw out this challenge, this question. What should your rational degree of belief be that the Earth's average temperature will go up, let's say, more than 4 degrees by 2080? Like maybe you think it's 0.75, but why not 0.75001 or 0.7497? It makes you realize, as a philosopher, how hard it is to justify being that precise about things in the real world.
And what's fascinating from a philosophical perspective is that this isn't a brand new problem. Way back in the 1800s, you had George Boole, big name in logic, probability, the whole formal system thing. Even he had this kind of unease about it.
Yeah.
He said, and I'm quoting here, "It would be unphilosophical to affirm that the strength of that expectation, viewed as an emotion of the mind, is capable of being referred to any numerical standard." For someone like him, a pioneer of these formal systems, to say something like that, it really highlights this intuition, this long-standing philosophical intuition that the subjective feeling of belief, of conviction, it's not always quantifiable. You can't just slap a number on it.
So it's like we might say our belief is this or that number, but the internal experience of that belief, it's not always that neat and tidy. And that's where this whole idea of imprecise probabilities comes in.
Right. Instead of saying, okay, my belief is represented by this one probability function, this one number, we consider a whole set of functions, a whole range of possibilities. The source calls this a creal set or a representer.
So it's more like acknowledging that there could be a bunch of different but plausible belief states rather than just committing to one specific one, kind of like a spectrum of possibilities.
That's a great way to think about it. And for a philosopher, a helpful analogy might be this creedal committee idea. Imagine a group of, let's say, very well-informed people, right? Each one of them has their own take on the evidence, their own slightly different interpretation. Now, instead of trying to mash all those opinions into one single judgment, the overall belief is represented by the whole spread of opinions within the group.
Okay, so that's kind of the philosophical appeal of not demanding a precise number for everything. But what are the actual philosophical reasons for using imprecise probabilities? What problems does this framework help us solve? And the source dives into this, laying out a bunch of arguments. One that jumps out, especially from a philosophical perspective, is this idea of Ellsberg decisions and ambiguity aversion.
Ah, the Ellsberg-Urn problem. Classic thought experiment in philosophy. It really throws a wrench into the typical way we think about rational choice. Here's the setup. Imagine an urn, right? It has 90 marbles. 30 are red, we know that. The other 60, they're either blue or yellow. But we have no clue about the proportions. And that lack of information, that's key here, philosophically speaking.
So you're in the dark about how many are blue and how many are yellow.
Exactly. And then you get a choice. You can bet on drawing a red marble or you can bet on drawing a blue one. Now, philosophically speaking, what do you think most people naturally go for?
Well, I guess most people would go for red, right? You know, the probability there, 1 out of 3.
You got it. Betting on blue, there's this unknown mix, this ambiguity. Philosophically, it shows that we tend to prefer risks that are well-defined, known risks, over ones where we're kind of in the dark. But then it gets even more interesting philosophically. There's a twist.
Yeah, the flip side, right. Bet on not getting blue or bet on not getting red.
Exactly. And here's the kicker. The preference often switches. People start to prefer betting on not red. This is super weird from a standard philosophical model of rational decision-making. No single probability function can account for both of these preferences. It's a violation of expected utility maximization, which is a cornerstone of a lot of philosophical theories of rationality.
So how does imprecise probability make more sense of this philosophically?
Well, instead of a single number, we can represent our belief about the blue and yellow marbles with a range. So the source says something like, okay, the probability of red, that's still 1/3, but the probability of blue and of yellow, that's somewhere between 0 and 2/3. It's this interval. Philosophically, this lets us capture that ambiguity aversion, that preference for knowing what you're getting into, whisk-wise.
So the imprecision itself reflects this very human thing, this aversion to the unknown, which is something that any good philosophical theory of rationality needs to grapple with.
Exactly. It's a key part of decision-making that precise probability struggles to capture, but imprecise probability handles it pretty neatly.
Of course, the source being philosophically rigorous, it mentions other ways to look at this Ellsberg thing too, right?
Right. It's important to be thorough. Some philosophers argue that these choices, they might be more about heuristics, these rules of thumb that people use when faced with uncertainty. It might not be a problem with precise probabilities themselves, but more about how we apply them, especially in situations where we don't have all the info. There's this manipulable odds idea, where people might shy away from bets if they feel like the odds are stacked against them because of the missing information. Philosophically, this brings up the whole debate between ideal rationality and bounded rationality, which is a fascinating discussion in itself.
Okay, so Ellsberg shows how imprecise probabilities might line up better with our gut reactions to ambiguous situations, which is a big deal for philosophical theories of decision-making. What's next on the list of philosophical reasons to go imprecise? The source talks about incompleteness and incomparability, and those concepts, they're pretty deeply rooted in philosophical discussions about values and preferences.
This goes deep into how our beliefs and preferences are structured. Precise probability often assumes this completeness, meaning that for any two choices you have, you either prefer one or you're indifferent, right? But philosophically, is that always true?
Yeah.
Especially when we're talking about big, complex, uncertain situations.
It definitely doesn't always feel that way. Sometimes you're just not sure. It's not that you see the options as equal. It's more like you just can't make a clear comparison. And that's a big deal when you're talking about philosophical ideas of choice and free will.
Exactly. Mark Kaplan, a big name in epistemology, he makes this distinction between indifference, where you've actually thought it through and decided the options are equally good, and indecision, where you just haven't gotten to that point yet. You're genuinely unsure. And imprecise probabilities, they let you represent that no determination state formally. You don't have to force a precise value or preference when it just doesn't exist. It's much more philosophically honest about what's going on in the agent's mind.
And there's this behavioral consequence of incomparability that the source mentions, which is pretty interesting philosophically. It says that incomparable goods are insensitive to small improvements. What does that mean, practically speaking?
Well, think about it. If you're truly indifferent between two things, a small improvement to one might be enough to tip the scales, right? But if they're truly incomparable in your mind, making one a little bit better might not suddenly make it the preferred choice.
Right.
That underlying lack of a clear basis for comparison, that's a deep philosophical point about how we assign value to things.
So Kaplan's saying it's not just that it's okay not to have a precise belief in these situations. It's actually more intellectually honest, more responsible not to, especially when the evidence is shaky. It's like demanding certainty where certainty just isn't warranted.
Exactly. He's arguing against this idea of precise beliefs as some kind of ultimate goal. It might be a good goal if you had perfect information, like knowing exactly how biased a coin is, but that's not the reality for most of us, especially when we're dealing with complex philosophical questions.
So not having a precise belief isn't always a sign of irrationality. It can actually be the more rational response, philosophically, when you're dealing with limited evidence. Now on to the third reason. Weight of evidence versus balance of evidence. This feels like a crucial distinction for any philosophy that's trying to understand how evidence actually supports our beliefs.
Absolutely. This is something James Joyce, a philosopher who's done a lot of work in this area, really emphasizes. Imagine this. You've got a coin, and you say the probability of it landing heads is 0.5. Now imagine two different scenarios that could lead you to that probability. In one case, you flip this coin thousands of times, a fair coin, and roughly half the time, it's heads. That probability, it's backed up by a ton of evidence. That's what we call high weight of evidence, which is philosophically pretty solid.
Okay, that makes sense. You've actually seen it happen, so your belief is well grounded. What about the balance scenario?
Now imagine a coin, but you have no idea if it's biased or not. You've never flipped it, you know nothing about it. But you might still say, okay, I guess the probability of heads is 0.5. You're basically assuming it's fair because you have no reason to think otherwise. That's high balance, but low weight. You get the same number, 0.5, but the reasoning behind it is way weaker philosophically.
So, same probability, but a totally different epistemic situation. That's a crucial distinction for any philosophy that wants to understand how we justify what we believe. And it seems like standard probability, it kind of lumps these two things together, doesn't it?
It does. Both scenarios end up with that same p-heads, equals 0.5. But with imprecise probabilities, we can potentially tease them apart. With the fair coin, the one with lots of evidence, we might represent it with a narrow interval, something close to or maybe even exactly 0.5. It reflects that strong evidence. But the unknown coin, the one with no evidence, that could be represented by a much wider interval, maybe even 0.1, which basically says, hey, we have no clue, it could be anything. Philosophically, this feels more honest about how much we actually know.
It lines up with this intuitive idea that the width of the range kind of reflects how confident we are in our belief. But the source does add a little caveat here, right? A little philosophical caution.
Right, of course. It's tempting to say, okay, narrow interval equals lots of evidence. But it's not always that simple, philosophically speaking. You could have conflicting evidence, which could also lead to a wide interval. So interpreting that interval, it takes some careful philosophical thought.
Now, those who like precise probability, they're not completely without options here. The source mentions resiliency and stability.
Yeah, those are interesting concepts. The idea is that probabilities that are based on a lot of evidence, they tend to be more stable. You get new evidence, it doesn't change them much. That's resiliency. And how much they change, that's stability. So even with precise probabilities, you might be able to tell the difference between the two coin scenarios by looking at how those probabilities would change with new evidence. It's a way to kind of get at this weight versus balance idea. But from a philosophical perspective, it's still not quite capturing that gut feeling we have in Ellsberg-type situations.
So weight versus balance, another point for imprecise probabilities. They seem to offer a more nuanced way, philosophically, to represent our states of knowledge. On to the fourth motivation, suspending judgment. This is a big one, especially in philosophy, skepticism, epistemology, all that good stuff.
This gets at a really fundamental point about what it means to have a precise probability, philosophically. If you give a proposition a precise probability, even a tiny one, you're saying you have some degree of belief in it. But is that always rational? Especially when you're really in the dark about something. Isn't it sometimes more rational, philosophically, to just not form a belief at all?
It's like when you have no information, sometimes the smartest thing to do is just admit you don't know. The source quotes Wally here. When there is little or no information, we cannot expect reasoning to reveal a most probable hypothesis or a uniquely reasonable course of action. That's a powerful statement about the limits of what we can know, philosophically.
And let's go back to that coin with unknown bias. A hardcore Bayesian, philosophically speaking, they have to give some prior probability to heads, even if it's just 0.5 based on symmetry. But someone using imprecise probability, they can say, nope, we're suspending judgment. They can use the interval 0.1, which basically says any probability is possible because we have no information.
Now, someone could argue that even with precise probability, setting it to 0.5 is suspending judgment. It's like saying, we're neutral, we have no opinion. How would someone who likes imprecise probabilities respond to that, especially in a philosophical debate?
They'd say that even setting it to 0.5, it's still a commitment, philosophically speaking. It means you're indifferent to bets at those odds. But true suspension of judgment, it should mean you're not willing to bet on either side. You have no conviction either way. And precise probability, it can't quite capture that. There's always going to be one side of the bet that looks at least somewhat okay.
So true suspension, it means not leaning in any direction. And the source uses this great example from Elga to make this point about precise probability and radical ignorance. It's the toothpaste and jellyfish example.
Ah, yes, that's a classic. It goes like this. A stranger shows you a toothpaste tube, then a jellyfish, and then another toothpaste tube. What's the probability that the next thing they show you will be another toothpaste tube? Philosophically, any precise probability you try to assign here, it just feels arbitrary. There's no clear method, no solid epistemic basis. It's a great illustration of how forcing a precise probability in these kinds of situations, where we're totally clueless, just doesn't make philosophical sense.
It really shows the limits of trying to squeeze everything into a precise number when sometimes the most honest answer is, I have no idea. And there's also Chandler's argument, which uses Bertrand's paradox to highlight how hard it is to represent a neutral state of belief, philosophically, using precise probability.
Yeah, Chandler's argument shows that if you try to suspend judgment about some variable x by giving it a uniform distribution, which is something precise probabilists might do to try to show neutrality, then you run into problems. Because if you look at a related variable, let's say y, which is just 1x, then you end up with a non-uniform distribution for y, which means you're no longer suspending judgment. It's an inconsistency that pops up because of the structure of precise probability itself. And it's a pretty big philosophical challenge for its claim to be the best way to represent belief.
So, being able to suspend judgment, that's another big plus for imprecise probability, philosophically. What's the next reason on the list? Unknown correlations. This feels like a very practical problem, but it also has deep implications for how we reason about complex systems, which is a huge area of philosophical interest.
It is. Think about it. In real life, we often have decent estimates for the probabilities of individual things happening. Let's say X and Y, whatever those are. But we might not know how they're related. Are they independent? Do they influence each other? Are they correlated in some way? We just don't know. And that lack of knowledge, it affects how we reason about them philosophically.
So, how does not knowing about these correlations lead us to imprecise probabilities?
Well, even if we have precise probabilities for X and Y individually, the probability of them happening together, that's Px and Y, that can't be pinned down to a single number. It's going to depend on how they're correlated. If they're independent, that's one probability. If they're positively correlated, that's a different probability, and so on. Philosophically, trying to assign a precise number to Px and Y, when you don't know about their correlation, it's like making stuff up.
Yeah.
You're assuming something you don't actually know.
So it's more intellectually honest, philosophically, to admit that we're not sure and represent that uncertainty with a range of possible probabilities.
Exactly. You end up with an interval instead of a single point. The source actually gives the mathematical formula for these bounds, which comes from Di Finetti's fundamental theorem of prevision. Philosophically, it's saying that any attempt to get more precise than that interval, it's going beyond the evidence. You're basically inventing information.
Okay, that makes sense. The next one is a bit more out there, philosophically speaking. It's non-probabilistic chances. This one kind of shakes up a basic assumption in both science and philosophy, doesn't it?
It really does. We usually assume in both science and philosophy that objective chances, those things in the world that determine how likely something is to happen, that they can always be represented by standard probabilities, following those classic probability axioms. But the source, they poke at that assumption philosophically. They say, well, is there really a solid argument for that?
So what if the world, at its most fundamental level, what if it's just not that neat and probabilistic? What if the chances themselves are fuzzy?
Well, if our beliefs are supposed to line up with these underlying chances, and that's a big if, philosophically, but if they are, then maybe our beliefs should also be fuzzy, right? Imprecise. Because if the chance of something happening is itself a range, then our belief about it should also be a range. That would be more philosophically true to the nature of the world, as messy as it might be.
The source gives some examples. Physical processes where things don't always happen with a perfectly predictable frequency. They kind of fluctuate within a range. Or some interpretations of quantum mechanics where things are inherently uncertain. These are pretty philosophically challenging ideas.
And they force us to reconsider some of our basic assumptions about how the world works. There's this philosopher, John Norton, who's argued pretty convincingly that probability, as a logic for understanding how the world works, it has its limits. He gives examples where it just doesn't seem like any precise probability makes sense. And imprecise probability, it might offer a way to deal with those cases, even though Norton himself is still a bit skeptical of the whole thing.
Interesting. Pushing the boundaries of how we think about the world and our place in it. The final reason for going imprecise is group belief. This is huge in social epistemology, the philosophy of how groups form beliefs.
When you move from a single person's belief to a whole group, like a committee or a government or something, you run into the problem of disagreement. People have different opinions. And a single probability, it just can't capture that. Isaac Levi, one of the big names in Imprecise Probability, he argued that a set of probabilities, that's a better way to represent the diversity of opinions within a group.
Because a single number, philosophically, it's like pretending everyone agrees when they don't.
Exactly. And some of the ways we normally try to combine individual probabilities into a group probability, they can lead to some weird conclusions, philosophically
That's
speaking. Like, let's say everyone in a group agrees that two events are independent. But if you try to combine their individual probabilities into a single group probability using a simple method, you might end up with a group probability that says the events are dependent, which is kind of crazy.
It's like the group is saying something that none of the individuals believe, which is a problem philosophically when you're talking about the relationship between individual and collective belief.
Exactly. And Levi also pointed out that even within an individual, there can be this kind of conflict, a lack of settled belief. It's like that creedal committee idea, but inside one person's head. Imprecise probabilities can model that internal conflict, which is pretty philosophically insightful.
Okay, so we've covered a ton of ground here, a whole bunch of philosophical reasons for why imprecise probabilities are worth taking seriously. But as with any new philosophical framework, there are going to be some questions, some challenges, and the source tackles a bunch of these. First up, dilation. This sounds kind of unsettling philosophically, like our beliefs are expanding in a way we don't want them to.
It is a bit unnerving. Dilation basically means that sometimes getting new information that seems totally irrelevant to a particular belief can actually make your range of belief wider. And that raises some big questions about what it means for information to be relevant and how learning should affect our beliefs, philosophically speaking.
The source uses this example with a fair coin. We know it's fair. And then there's this other proposition, X, something we know absolutely nothing about. It seems like learning whether X is true or false shouldn't change our belief about the coin flip at all, right? But in some models of imprecise probability, it does.
Right. This is a puzzle that a philosopher named Roger White pointed out. Because our initial belief about X is so vague, it includes possibilities where X might be relevant to the coin flip and possibilities where it's totally irrelevant. So when we learn about X, our belief about the coin flip becomes more vague too, even though we know the coin is fair. And that feels wrong to a lot of people. It's like irrelevant information is making us less certain, which seems to go against basic philosophical ideas about how knowledge works.
It feels like it's violating this philosophical principle of informational parsimony. Like, why should we become less certain when we learn something that's irrelevant?
Exactly. And White argues that this violates the reflection principle, which is a big deal in epistemology. It says that what we believe now should be consistent with what we expect to believe in the future. So if we know that learning about X is going to make us completely uncertain about the coin flip, regardless of what we learn, then shouldn't we already be completely uncertain now? That's the philosophical tension.
But the source does offer a counterargument to this whole dilation is a fatal flaw idea.
Right. They point out that even though the range of probabilities for the coin flip might get wider, the actual set of probabilities changes. The individual functions within that set, they all get updated in a way that makes sense. So dilation, it might be less about our beliefs getting messed up and more about how we're representing those beliefs. Maybe focusing just on the range of probabilities is misleading.
So it might be more about the interpretation of the model than a problem with the model itself, philosophically speaking. And maybe our initial certainty about the coin flip, maybe that was a bit premature given that we were so uncertain about this other thing, X. The source also mentions how dilation messes with this idea that information is always a good thing.
Yeah, and in standard probability theory, getting more information is supposed to make your beliefs more accurate, on average. But dilation kind of throws a wrench in that. It seems like sometimes more information makes us less certain. But the debate is still ongoing about how to properly understand the value of information in the context of imprecise probability, which is a fascinating philosophical question.
Okay, so dilation, it's tricky, but maybe not a deal breaker for imprecise probabilities. On to the next challenge. Belief inertia. This sounds like the opposite of dilation, right? Like our beliefs are stuck, they refuse to change.
This one comes up when you start with a completely uninformative prior belief. Like you're saying, I have no clue about this hypothesis H1, so my probability for it is anywhere between 0 and 1. The problem is, if you start with that much uncertainty, then even after you get new evidence, your belief might still be anywhere between 0 and 1. It's like you haven't learned anything at all, which is a problem philosophically.
Yeah, it's like the evidence just bounces off. It doesn't make a dent. That goes against the whole idea of learning and how our beliefs should change with new information.
Exactly. Levi One of the founders of imprecise probability, he recognized this problem early on. Wally, another big name in the field, he argued that if your prior belief is completely uninformative, then your posterior belief, the one after you get evidence, it should be uninformative too. It's like you started with, I have no idea, so it makes sense to end up with, I still have no idea. But other philosophers, like Joyce and Renard, they've argued that this means maybe we shouldn't be using completely uninformative priors in the first place. It's a debate about the very starting point of how we form beliefs, which is a fundamental philosophical question.
So if you're into imprecise probabilities, how do you deal with this belief inertia problem?
There are a bunch of ways people are trying to solve this, mostly by tweaking the rules for how we update our beliefs in imprecise probability frameworks. One idea is to get rid of those extreme prior probabilities, the ones that say the evidence is practically impossible. It's the work in progress, philosophically, trying to figure out how to make sure we actually learn something even when we start from a position of not knowing much at all.
All right, the next challenge is a big one: decision making. At the end of the day, our beliefs are supposed to guide our actions. So, how do we make decisions when our probabilities are imprecise? It's like we have a committee of beliefs, each with their own opinion.
That's the tricky part, philosophically. If each member of that creedal committee has their own slightly different take on things, they might each recommend a different action. And that can lead to a situation where you just can't say which option is better. They're incomparable. The classic example is that coin with unknown bias. Should you bet on heads or tails? Well, if your range of beliefs is wide enough, the expected value of each bet might overlap so much that there's no clear winner. Philosophically, that's a tough spot to be in.
And Timothy Williamson, a pretty influential philosopher these days, he's worried that this could lead to decision paralysis, where we're so unsure that we just can't act. That's a big problem for any theory that wants to be practical, especially in philosophy, where the goal is often to figure out how to live a good life.
But remember, one of the reasons people like imprecise probabilities is precisely because they can represent that incomparability. It's like saying, hey, sometimes we just don't have enough information to make a clear choice, and that's okay. Maybe the most rational thing to do, philosophically speaking, is to acknowledge that uncertainty and not force a decision when one isn't really justified.
There's this example in the source, the sequential betting problem with the unknown coin. If you refuse both bets, you miss out on a guaranteed profit if you accepted both. But some imprecise decision rules say it's okay to refuse. That seems weird, right?
It does seem a bit counterintuitive. Some philosophers, like Elga, have used this kind of example to argue against imprecise probability. They say it leads to irrational behavior. But others argue that it's not irrational, it's just being cautious. When you're really unsure, maybe the best thing to do is just wait for more information. And there's this interesting philosophical connection to moral dilemmas where the options can also feel incomparable. So the whole question of how to make decisions with imprecise probabilities, it's still an open area of research in philosophy.
So decision-making with imprecise probabilities, it's definitely more complicated, but it might be a more accurate reflection of how we actually make decisions in the real world, which is often messy and uncertain. The next question is about how to interpret imprecise probabilities. What do these sets of numbers actually mean when we're talking about our beliefs? And that's a pretty fundamental question for any philosophy of mind.
The source makes this comparison to physics. Think about Newtonian mechanics and Einstein's theory of relativity. For everyday stuff, they pretty much give you the same answers. But the way they think about the universe, it's totally different. Relativity has this whole different concept of space and time. Imprecise probability, it's kind of like that. It might lead to similar actions as precise probability in a lot of cases, but philosophically, the way it understands ignorance, it's just different. And that raises questions about what our models of belief are even for. Are we trying to describe how our minds actually work, or are we setting up some kind of ideal standard?
It's like, do we want our models to be accurate to how things really are, even if it's messy, or do we want them to be elegant and simple, even if they're not totally realistic? And the answer might depend on what you're trying to do, philosophically speaking. Exactly. The source goes on to talk about all these different philosophical ways to think about degree of belief. There's the betting interpretation, where your degree of belief is basically the odds you'd be willing to bet at. There's the idea of belief as a tendency to act in certain ways. There's the psychological view, where it's all about mental states. And then there's the functionalist view, where belief is defined by its role in decision-making, reasoning, and all that. Philosophers like Williamson, they really like the betting interpretation, and they have problems with imprecise probability precisely because it doesn't fit that model very well. So how you evaluate imprecise probability, it really depends on your underlying philosophy of mind.
But you could also argue that forcing someone to give a precise betting odds when they're really uncertain, that might actually be a misrepresentation of their true belief. In a functionalist approach, it might be more open to the kind of nuance that imprecise probabilities allow for. And here's a key point, philosophically speaking. Just knowing the range of probabilities for something, that doesn't tell you everything you need to know about someone's belief. There's a lot of information encoded in the structure of that whole set of probabilities, the creedal set. Like, saying that your belief about a coin flip is anywhere between 0 and 1, that's different from saying that you have a bunch of different beliefs, each with a different probability, but they all add up to 1. So for a full philosophical picture of belief, you need to look at the whole creedal set, not just the individual numbers.
So there's a deeper philosophical story being told by the structure of that set. Now let's talk about regress. If we're using sets of probabilities because we're uncertain about the exact probability, why not use sets of sets? Like, why shouldn't we be uncertain about the sets themselves? This gets into some deep philosophical waters about how far we can go in representing our beliefs.
This is the problem of higher order vagueness. If we're unsure about one level of belief, why not be unsure about the next level up, and so on? It's like an infinite loop of uncertainty. Williamson and some other philosophers, they worry about this. They say we should just stick with a single probability and be done with it.
But then we're back to square one, right? We lose all the benefits of imprecise probability, all that nuance and ability to represent real-world uncertainty.
Right. And people who like imprecise probability, they argue that we don't need to go down that infinite regress rabbit hole. Sets of probabilities, they strike a good balance. They're